In this lecture, we'll be talking about oxidation and reduction. You're probably already familiar with some oxidation-reduction reactions that occur in nature, such as the oxidation of iron, which causes it to rust. But before we go into oxidation-reduction reactions, let's look at oxidation states. The oxidation state of an atom is the total number of electrons that an atom either gains or loses in order to form a chemical bond with another atom. What you see here are a few rules that help to determine the oxidation state of the different atoms in a compound. For example, metal ions usually have a positive oxidation state, with group 1 metals having an oxidation state of +1 and group 2 metals an oxidation state of +2. Nonmetals generally have a negative oxidation state. Hydrogen and oxygen atoms are two special cases. The hydrogen atom has an oxidation state of +1 when combined with a nonmetal and -1 when combined with a metal. Oxygen generally has a -2 oxidation state, except when it is in the peroxide ion, then its charge is a -1. The total charge of elements or atoms in their elemental form, such as oxygen or chlorine, is 0. So both these species have an oxidation state of 0. If we look at ions such as sodium chloride, we know that sodium has a +1 oxidation state because it is a group 1 metal. So that means that chloride must have a -1 oxidation state to make the total charge of sodium chloride 0. In our second example here, the hydrocarbon ethylene consists of carbon and hydrogen. Since we know that hydrogen has an oxidation state of +1 in nonmetal compounds, this means that the carbon atoms must have a -2 oxidation state here. Now that we know how to determine the oxidation state, let's take a closer look at oxidation-reduction reactions, which we generally abbreviate to redox reactions. Redox reactions are chemical reactions in which electrons are transferred between species. On this slide, you can see two atoms, atom A and atom B, which undergo a redox reaction. Initially, the oxidation state of A and B is 0. They are electrically neutral atoms on their own. However, after the electron transfer has taken place, the oxidation state of A is positive and that of B is negative. We say that A has been oxidized. It has lost electrons, making its oxidation state positive. At the same time, B has been reduced. It has gained electrons, which makes its oxidation state negative. In redox reactions, the species that loses electrons is oxidized, while the species that gains electrons is reduced. If you find it difficult to remember whether the oxidized species is the one that loses or gains electrons, just remember oil rig. You know those big structures that they use to drill for oil? Oxidation is loss of electrons and reduction is gain of electrons. To better understand what happens in these electron transfer reactions, chemists like to write them in two parts. They're called half reactions. What you see in this table are a number of different half reactions, where the left column shows oxidizing half reactions, so half reactions where electrons are lost, and the right-hand column shows reducing half reactions. In any given redox reaction, there are two half reactions occurring, and the sum of these half reactions is the redox reaction. Half reactions are very useful if you want to balance redox reactions. In a balanced redox reaction, there needs to be exactly the same number of electrons on each side of the equation. In our example, the chlorine half reaction has 2 electrons as reactants, while the sodium half reaction has only 1 electron as product. And this means that we'll need to multiply the entire half reaction of sodium by a factor 2. And now we can add these two half reactions to form the full redox reaction. And because we have 2 electrons on each side of the equation, they can be cancelled. And this makes the overall redox reaction, which you can see is balanced in terms of elements as well as charge. You can tell whether a reaction is a redox reaction by looking for changes in oxidation number. Typical examples of redox reactions are combination reactions, decomposition reactions, and combustion reactions. When there is no change in the oxidation number of any of the elements taking part of the reaction is not a redox reaction. In the energy transition, we also see a lot of redox reactions. Just think about one of the examples I mentioned at the start of this module, where knowledge of chemistry is used to convert CO2 into useful chemicals such as ethylene. There is quite some electron transfer going on in these reactions. Now it's time to practice with these redox reactions and have reactions yourself. Good luck!